So, in last class I was discussing the propagation of error, means that this physical quantity generally we cannot measure directly in our laboratory. So, we calculate the physical quantity from the relation with the measurable quantity, measured quantity in the laboratory. So, if this relation is in form of summation and differences, then how to find out the error on the physical quantity, that I have discussed, and that is the first rule for propagation of error. Now, I will discuss if this relation is in product or ratio form, product or and quotients form, then what will be the error of the physical quantity. So, same way if we proceed. So, this for products and quotients. So, that means relation this q equal to x y or q equal to x by y. Okay. So, then let us see this what will be the error delta q. So, x as usual x base plus minus delta x, y equal to y based plus minus delta y. Okay. So, then in this case, so in case of summation we just discuss or consider the error, that is called absolute error, but in this case we are considering fractional error, okay, or yes, what it is called relative error. Okay. So, that is defined by delta x by x based, and for y this delta y by y based. So, this we generally write just delta x by x and delta y by y. Okay. So, this is the error in form of fractional or relative. Okay. So, why we have taken consider the fractional error, that you will understand just after this calculation. So, now so this by the measured parameters, and I know the delta x, I know the delta y. Okay. So, I can find out the fractional errors delta x by x and delta y by y. So, now x equal to basically x based plus minus delta x. So, if I take common this x base, I can write 1 plus minus delta x by x. So, this I have put in mod. So, whether x is positive or negative, but we will take positive value. So, that is why mod x. Similarly, y equal to y based, if we take common, so then 1 plus minus del y by mod y. Okay. So, then q equal to x y, x is x based. So, I put these two value here, then what I will get x based, y based, then 1 plus minus del x by mod x plus minus del y by mod y, okay. Then plus minus del x del y by mod x mod y. Okay. So, this just I cancelled it, I have not considered this one, because is the second order, we tell the second order error, means first order, second order, third order is a higher order error, is its value will be very small compared to this other two first order error. Okay. So, forget first order, second order, but from here you can see, because this the del x del y very small, now is in decimal point generally, and now multiplication of these two, okay, obviously del x del y is even smaller, it will be very small compared to this one, and this denominator also this multiplication of these two. Okay. So, it will be high value. So, then basically this term last term is very small compared to this other these two terms. So, that we do not consider this one, we neglect it. Okay. So, then ultimately, so q equal to you are getting x based y based, then 1 plus minus del x by x plus minus del y by y. So, if we compare with this q based, okay, so from here you can tell this limit of this q value, largest value of q and smallest value of q. Obviously, largest value of q if you take plus of both cases, and smallest value if you take minus in both cases. Okay. So, so your q equal to q based plus minus delta q equal to q based plus minus delta q equal to q based, if you take common 1 plus minus delta q by q based, mod q based. So, generally we take just write q. So, if you compare with this one, whatever I have we calculated from here. Okay. So, if we compare with this one, so that is x based y based 1 plus minus del x by x plus minus or I have taken common. So, plus del y by y. Okay. So, if you compare, then q based equal to x based y based, q based equal to x based y based, and delta q by q based, that is just we generally write q, okay, mod q, then that will be equal to del x by x plus del y by y. Okay. So, in this case what we are seeing? In this case we are seeing that this in case of product or quotients, okay, or ratio, the error again it is the summation of the individual errors, but it is not absolute error, it is in form of relative error. So, in case of product and quotients, the error on the physical quantity will be the summation error on the physical quantities. So, that is relative error or fractional error on the physical quantity will be the summation of the fractional errors of the individual parameters or quantities or measured quantities. Okay. So, that is why in this case we have taken this considered the fractional error, and other case we have considered the absolute error. So, this is basically second rule. In case of product or quotients, the relative error of the physical quantity will be equal to the summation of the relative error or fraction errors of the measured quantities. Okay. So, whereas this first rule what we have seen, for summation and difference, absolute error or summation of the absolute error of the measured parameters or measured quantities, that will be the error of the physical quantities. Okay. So, this okay. So, that I showed you just for calculation, I showed you for product. So, here I have calculation for the ratio also quotients, and same way we have shown that in this case also this result is same. Just quickly I will show you this calculation. So, q equal to x by y. So, that means x based 1 plus minus del q by x, y based divided by y based 1 plus minus del y by y. Okay. So, then from here largest value of q what will be? So, largest value means this numerator has to be large and denominator has to be small. So, I will consider here plus and I will consider here minus. Okay. So, then this value will be large value, and from here I have written x based by y based. Then you see this 1 plus or minus something. Okay. If it is very small than 1, then binomial theory you can use. So, this we can write 1. So, this we can take off. So, this is basically 1 minus this minus 1 power minus 1. So, that that is equal to the 1 plus del y by y. So, from binomial theory you can write. So, that is what I have written 1 plus del x by x, and this one 1 by this one is basically 1 plus del y by y. Okay. So, again this here you can see this for largest value, these both are plus, and similarly, and this if you multiply, then neglecting this second order term, you will get this one. Similarly, for smallest value of q. So, this numerator has to be smaller and denominator has to be higher. So, this here we have considered minus, here we have considered plus. So, if you take up, so this will be 1 minus this into 1 minus del y by y. So, so from there you will get 1 minus del x by x minus del y by y. So, now this del x by x plus del y by y, this the this 1 minus of this one. Okay. So, in this case also you are getting del q by q. If you just proceed here, calculation steps are given. So, del q by q equal to del x by x plus del y by y. So, in case of ratio also we are getting this summation of the individual error, relative error of the measured parameters. Okay. That will be the error, relative error on the physical quantity. So, in both cases, as I told, this in for product as well as for quotient, rule is that the relative error of the physical parameter is equal to the summation of the relative errors of the measured parameters. Okay. So, rule in general, then rule is for product and quotients. This is the second rule. If several quantities x, y, z, u, v, w are directly measured with errors del x, del y, del z, etcetera, del u, del v, del w, and the calculated quantity q is related with x, y, z, u, v, w by relation q equal to this way. Okay. So, here both multiplication as well as divisions are there. Then the fractional error in the computed or calculated value of q is the sum delta q by q equal to this sum of all individual errors, relative errors, that will be the fractional errors. These are the basically summation of the fractional errors in x, y, z, u, v, w. Okay. So, this is the second rule, okay, for propagation of error. So, we already discussed about the summation and difference or subtraction or product and quotients or divisions or ratios. Okay. So, let us consider some special cases. We need to consider, because in real example in laboratory different kind of relation we will see, and there the special whatever we will discuss, this type of relation also may be there, not only summation and difference products and quotients. Some other special relations may be also there. Here let me discuss a few of them. So, if relation is like this, q equal to bx, not xy, bx, where b is constant basically, okay, means b is not measured, okay, is the given value or some constant. Okay. Then we can tell the no uncertainty in b, uncertainty with b is 0, means del b equal to 0, delta b is equal to 0. Okay. So, in this case what will be the error on q? Okay. So, as for example, this for this in case of if you are asked to calculate the circumference of a circle, so then relation is c equal to circumference of the circle, c equal to pi d, d is the diameter, okay, or 2 pi r, r is a, r will be the radius. Okay. So, basically for that what you have to do, if you want to find out the circumference of a circle, you have to measure the. So, what you will measure? You are not measuring circumference directly, basically you are measuring d, diameter of the circle. Now, from this relation you will find out the circumference. Okay. So, what is the error on this circumference? So, here basically you can take it as a just product form b and x, product form of b and x. So, for product what happens? So, relative error for on both cases will be added. So, I can write del q by q equal to del b by b plus del x by x, del b equal to 0. So, then del q by q equal to del x by x. So, del q one can write del x by x into del q into q mod q. Okay. So, if you put this value of q, that is b x, okay. So, you will get x x will go and then you are getting basically equal to b delta x. So, from here what you are seeing? You are seeing that if the quantity x is measured with the uncertainty delta x and is used to calculate the q equal to b x, where b has no uncertainty. So, then uncertainty, absolute uncertainty in q is just the b times that in x. Okay. That means delta q equal to b x. So, from here from this calculation, okay, based on the our known rules, rule 3, rule 2, okay, for product case, just considering that one. So, here we found that if one measured parameter is multiplied with a constant which is not measured. So, uncertainty is 0 on that constant, then the absolute error will be just that constant into the error in the measured quantity, that is delta x. Okay. So, this is one case. If we face another case like this form, q equal to x to the power n, okay, q equal to x to the power n. So, just consider this one example, this what is the kinetic energy of a body if its velocity is v. So, kinetic energy I can write half m v square. Okay. So, for this case now we want to find out what is the error on k. If so, then here basically we are measuring our measured parameter or quantity is v, okay, and then we have to calculate v square. So, v square is nothing but v into v. Okay. Forget half m right now because they are constant and you know this, if constant is multiplied with, so already we know, but now square of it. So, but we are measuring v, but here in relation v square is there. Okay. So, here we are how to what will happen for this v square. So, that is what we are discussing. So, v square one can write v into v. So, it is simple this multiplication of the two parameters, although they are same, but it is like x y form, x into y form, but both are same, they are not different. So, but rule will be applied on this. So, obviously, relative error will be del for this del v by v. Okay. So, del v by v plus del v by v, okay, summation of the relative error. Okay. So, that will be 2 del v by v. So, then we can generalize it that if power is n, then relative error will be n times of the relative error will be n times, right, will be n times, mane n. So, n times of the relative error of the measured parameter. So, obviously, for this case del q by q will be equal to n del x by x. Okay. So, that is what here. So, this what we got, if this type of power is there. So, this error will be this power times this error, relative error of the measured quantity, measured parameter. So, I think this we are, so we do not need to consider this, okay, multiplication etc. So, this from knowing these rules of multiplication, from there itself these two cases I showed you. This one is if constant is multiplied with the parameter, if this parameter have power. Okay. So, then what will be the error? So, directly we can use this just multiplied with constant in case of absolute error, multiplied with this power in case of relative error. Okay. So, for these two cases. So, this way there are more special cases, but whatever I discuss or whatever rules I discuss, using that one you can calculate for most of the, I think for all relations of the measured parameters with the physical quantity. Okay. So, there is some, I think, so far what we got, what we have seen, when measured quantity are added or subtracted, the uncertainties are added, absolute uncertainties are added, right. When measured quantities are multiplied or divided, the fractional uncertainties are added. Okay. These two rules we have seen, we have verified, we have proved. Okay. So, now if the measured parameters are independent and random, if measured parameters are independent and random, okay, in that case, so statistical laws governed. In that case, basically we can modify this, that error, whatever so far we have seen. So, that is what is a discussion is we are doing, we will discuss about it. Just I will mention, basically I will not go for that much depth. So, basically statistical laws, because random error mostly is a statistical in nature, and statistical laws governs our errors in measurement. If measurements subject to random uncertainties. Okay. So, in case of random uncertainties, so this statistical laws governs the errors in measurements. So, there I think the statistical part I will not discuss, but you know this if you measure, if you repeat the experiments or yes. So, basically and many datas, if you collect many datas and we plot it. So, all data is supposed to be if it will be very accurate if all data you get of same value, but this never happens. These data are distributed. Okay. So, and this distribution generally in different form, it is in, it may be Gaussian distribution or normal distribution or I think Lorentzian distribution, etc. Okay. So, in that case generally this standard deviation, we consider the error as a standard deviation, and that standard deviation, you know, this in Gaussian form, this there is some calculation, the height we considered or this is the width we considered at a particular height, where the 70% data will be within the 68% will be within the error range, okay, plus minus the standard deviation if it is sigma, and then your best value generally peak value we take, that is x best plus minus that sigma, okay. And the standard value sigma, it's generally comes, you know, this in square root form, okay, in square root form. Okay. So, if your measurement is statistical in case of random uncertainties, so then the uncertainty in q equal to x plus y can be written or is given by del q equal to square root of del x square plus del y square. So, earlier we have considered del q equal to del x plus del y, but instead of it, in when this your experiment is in statistical nature, then the error will be square root of this square root of the square of this errors on x and square of the plus square of the errors on this. Okay. So, whatever we have calculated, just if we put square root of it, taking the square of these individual errors, then that will be the error. Now, obviously, this is less than del x plus del y. So, here basically it is telling that if you consider this del x plus del y, then your error is, you are overestimating your error, but actual error should be like this. And now, only restriction, this it is only valid for independent and random uncertainties, So, error is in random type, as well as the parameters are related with the q or physical parameter related with the physical parameter. So, they are independent. Okay. So, in that case only it is. So, but generally in our laboratory, whether it is statistical in nature or it is a normal experiment, in all cases we considered, we do not consider this one square root of this, we consider del x plus del y. So, that is why this, and this is the maximum possible error. So, that is why the error, this del q equal to del x plus del y in this form in our laboratory we will take. That is why this error is also called most probable error, or is called most probable errors. Okay. We tell this, okay, percentage error, most probable error. So, in our laboratory basically we will find out the most probable error, because this, as here just I discuss to tell you that the error we are, whatever we are the way we are finding out, okay, and taking the error on the physical quantity. So, that is the del q equal to del x plus del y. So, that is basically overestimated, that is why it is the maximum error, okay. And error can be smaller than this if it is in statistical nature, but in general that we will not consider. So, that is why in laboratory we will use whatever we have seen the form of the rules whatever we have established. So, that will follow in our laboratory also. So, that will be the overestimated, but this is the maximum value of the error. We can tell this that will be the maximum value of error, but error can be actual error can be smaller than that. Okay. So, now just we considered this yes. So, some relation summation or difference or product or quotients. So, here if you deal this parameter q, physical parameter q is not a the relation is not with one or with more individual parameters, measured parameters, but it is a function of one variable. Okay. If so, then how to find out the error? So, q equal to is a function of x. Okay. So, q equal to q function of x, and x is measured parameter. So, x equal to x based plus minus del x, right. So, del q, now we are interested to find out this error on this q. So, del q we can write this q is a function of x. So, q x is x based plus, I think it should be plus minus okay. So, I think we are taking the maximum value here, yeah. So, q is we are taking this maximum value here, q that is a q based plus del q, okay, minus q of q based. Okay. Q is a function of x. So, for x value x based plus minus del x. Okay. So, that x here. So, this del q we can take this, okay, for this value of the q for x based plus del x minus q x based. Okay. So, this is the function, and then this is nothing but the one can write dq by dx, change of q with respect to x into this delta x. Okay. So, this the this way basically we find out the differential form. Okay. So, differential form of this. So, you are familiar with this. So, this del q is basically one can write dq by dx into delta q, fine. So, it is the q x plus u minus q x, it is nothing but equal to dq by dx u. Okay. So, that is the things here we have written. So, as for example, this if q equal to cos theta, okay, physical parameter q, that is the is a cos function. Okay. It is a cos theta, it is a function and it is a cos function is theta. We are measuring theta and theta equal to say 20 plus minus 3 degree. So, what will be the error on q? So, I can write del q equal to, I know del q equal to this. So, del q means del cos theta equal to the dq by d theta, means d cos theta by d theta del theta, and they said here only you have to see that del theta when you are writing, that is the basically in radian, you have to take in radian. Okay. So, d cos theta by d theta is mod we are taking. So, it is basically it is minus sin theta, but we are taking mod. So, sin theta del q del theta in radian. So, sin 20 degree and it is a 3 degree in radian is a 0.05 and sin 20 degree 0.34 into 0.05 equal to basically 0.02. So, this del q is this. So, now cos theta, this q is cos theta. So, cos theta for this value we can write the result equal to 0.94 if you add this to 0.94 plus minus 0.02. Okay. So, this way one can calculate the error in case of function form of the physical parameters. So, this way one can basically calculate of different calculate of even for function form of the variables. So, there are many things, but whatever main things I am discussing, and it will be. So, these rules we will use for when we will do experiment in laboratory, and if I find some more examples where these rules are not enough. So, I think I will discuss some other special cases also, because this is huge subject. So, it is difficult to cover, but then it will be complicated, but our purpose is to tell you, my purpose is to tell you whatever you need in your laboratory, at least for teaching laboratory, at least this much concept I should give you. So, I think yeah, I will stop here, and then there are some more steps for propagation of errors I will discuss in next class. Thank you.